Alright, this is just a quick demonstration on incident response. One of the first things if you come across a powered on, logged in computer. Today it's imperative with all the different technology that's out there that we preserve anything that is currently going on the computer. For instance, what you're looking at right here is an incognito browsing window. So this is Google Chrome. It looks like they were doing a Google search for how to delete computer evidence, so it can't be recovered by law enforcement. If we close an incognito window, all of that evidence is gone. Nothing is being saved to disk. If we look behind it, what we have is a Tor browser window. So this is not only an incognito browsing window, but this person, who looks like they are signed into this dark web marketplace using the Tor browser, and based on the windows, it appears they are looking at purchasing 3 grams of cocaine. Again, if we don't take immediate action to document this, it is gone. So one of the first things law enforcement should do when they come across the powered on, logged in computer, is they plug in their incident response drive with all their incident response tools and they image RAM. One of the most common ways is with something like FTK Imager. You can see right here I launched FTK Imager for my incident response drive, and right there is the capture memory icon. After selecting the icon, you give it a location to save RAM, and of course, you never save anything to the location system. You always save it to my incident response drive. I will call this RAM image of Dell computer. We click capture memory, and it is right now imaging RAM. Alright, as you can see, RAM was successfully imaged with FTK Imager. Now I'm just going to minimize this for a moment because I want to show you how we could also image RAM with magnet RAM capture. Magnet RAM capture is just as simple as pointing to the location where you want to save the image of RAM, which of course is your incident response drive. I will name the file RAM capture of Dell laptop computer, saving it back to our incident response drive, and we hit start and it's going to save that 9 gig of RAM. Okay, as you can see, we successfully captured RAM. The next critical thing is to check for encryption. We do this using a free utility on our incident response tool called Encrypted Disk Detector by Magnet Forensics. We always want to check for encryption on any computer that is powered on and logged in, because if there is encryption, possibly Microsoft BitLocker, DriveCrypt, or VeraCrypt, we need to take immediate action because on a live system, the decryption key is in RAM, and it's not guaranteed that we can recover that decryption key from RAM and use it. So here, we see that the T drive has no physical drive, which is an indication it might be encrypted. At the same time, we see that the VeraCrypt process was located, so there's a good chance that this is a VeraCrypt encrypted image. So what I'm going to do next is, as long as the encrypted drive is mounted, meaning the user has put in their password to show the contents of the encrypted drive, we can create a live logical image and capture everything in an unencrypted state. You may be asking, how is that possible? Well, when a user enters their password to access encrypted data, the decryption key is held in RAM. When a user wants to look at a file, the encrypted data is pulled off the disk, and as it goes through RAM, it is presented to the user unencrypted. A live logical image does the same thing. As it reads each file off the encrypted drive, it passes it through RAM, where it is decrypted, and then saved to the forensic image, unencrypted. This is a one-time shot law enforcement or incident responders have to preserve encrypted data in an unencrypted state. If they miss this opportunity, it is likely they may never gain access to the encrypted data again. Here under Create Disk Image, or from the toolbar we select File, then Create Disk Image. We can create a logical image because a logical image will capture all of that encrypted data in an unencrypted state. So we simply point it to the logical image. And we're going to use the EO1 image format. We can put in our case number, etc. Give it a location where we want to image it to. Okay, so as we can see here, this was the hash that was computed before a copy was made, and this is the hash that was computed of the copy. You can see they both match. This is the MD5 hash, and this is the SHA-1 hash. So because the hashes match and we found no bad blocks, everything is identical, a perfect copy. Now we can go ahead and close this, and for demonstration purposes only, because we would never do this on a live original evidence computer. But what I'm going to do is I will compare the live logical image with the encrypted drive with File Explorer. I'm going to open up this forensic image we just created, and we're going to compare it to what we see on the live system. We come over to the T drive, we can see what's in the drive. It appears we have around 23 items in the T drive, and we don't see any contraband here. But if we look at the live logical image, what we can see is we've got several deleted items of contraband that don't show up on the T drive. That is because they have been deleted. Perhaps the person knew law enforcement was on the way and tried to delete their evidence of criminal possession. Next, if the operating system drive was completely encrypted, it is possible, even with the password, we may lose access to the data and never be able to access it again. During incident response, we could create a rapid live triage image with a tool called KAPE. By launching KAPE, we can point it at the C drive and choose an output location of our incident response drive. Now let's create a directory called Triage Image. We will select our pre-programmed forensic artifacts, and now we're going to tell it to process all volume shadow copies, and we're going to collect all that information in a compressed virtual hard disk container we will call Triage Image. Here we can see in only 562 seconds, the rapid triage collected over 90% of the forensic artifacts we will need to analyze this computer. Now that is rapid response. With the rapid triage completed, we can go take a look at the console log, and this is our audit log of exactly what happened. That is our standard incident response procedures for any Windows computer incident responders. Fine that is powered on and logged in.